Okay, so those are the types of IDs. Those are the ways that we establish IDs. Let me talk a little bit about how we establish the uniqueness of those IDs. How, for example, do I know that when your student number 173654, that there's no other student that has that student ID? Well, one thing that's really easy to do, and this is done quite a bit in databases, is to just use sequential numbers and never go backwards. Every time I assign an ID to something, to somebody, some student or whatever, I increment the number. I add 1 to it. And I never ever reuse numbers. So every time I have if I have student number 1,000, the next one up is going to be 1,001. If student number 1,000 drops out, I don't go and give that number 1,000 to somebody else. I would give 1,002 to the next person that came along. So by always incrementing, by always using the next higher number, I assure that every ID that I give out is unique. Very simple and very effective, except if I'm spanning different systems. So for example, if I have all the universities in Washington all giving out numbers, they all have to know what's the next available number, right? Because if I give one out at University of Washington, say I give one out at University of Washington, Seattle, and then I give the next number out at University of Washington, Tacoma, they all have to know about each other in order to make sure that the next number is unique. So that's kind of a problem. So we have another way of doing it, and this is my favorite way actually of creating uniqueness, because it's kind of slick, and it's interesting to me. And the idea is to give out a random number. So suppose I said, anytime a new student comes into the university, I'm going to give them a random number between 1 and 10. Would that work? Would that give me uniqueness? No, really, not at all. Okay, so I say, okay, between 1 and 100. Does that give me uniqueness? No way. 1 in 1,000? No way. 1 in 10,000? No way. 1 in 100,000? No way. 1 in a million? Most of my numbers are going to be unique. A random number between 1 and a million. But I bet you I'm going to have a bunch of times where that doesn't work. 10 million, 100 million, a billion, a zillion. You know, we can have numbers larger and larger and larger until we get to the point where it's really almost impossible for us to give the same number twice. And that's the idea of a globally unique identifier, a GUID, a GUID, or sometimes called a GUID, and other people call it a GUID. GUID, Globally Unique Identifier, GUID. We choose a random number we choose a range of numbers so high that it's so improbable that we'll assign the same number twice as to be close to impossible and guarantee uniqueness. Now think of what's interesting about that is that anybody, anywhere could be generating these unique IDs, and no matter who you are, you don't really need to know about anybody else, and it's almost guaranteed. I would say, you know, for all intents and purposes, it is guaranteed that that's going to be a unique ID. One other thing to know about GUIDs is that they don't use digital. They don't use base 10 numbers. So it's not from 1 to 100 billion. It's a base 16 number. And so when you look at a GUID, like you can see on the screen here, you see that it's a combination of numbers and letters. And I don't want to go into the technical details of what the letters mean, but understand that that's still a number. We're just using letters to make it even a bigger number than it would have been otherwise in the same amount of space. All right, so to guarantee uniqueness, we can use sequential numbers. But if we use sequential numbers, everybody assigning those numbers has to be aware of each other. To guarantee uniqueness, we could use random numbers, but we better make sure that it's random numbers in a very, very large range. So we create this idea of a GUID, anybody can apply them. Very, very unlikely that any two people are going to come up with the same number in that random number sequence, in the random number range. And so those work very well, but they're kind of clunky. As you can see, this number is enormous and it's a little clunky, right? Or we can do what's very often done, and what's done with web addresses, it's done with most of your IDs that you use on the web, and that's to have some sort of directory that says, well, if if that one's already taken, we're going to tell you, and you're just going to have to choose another one. So when I create a web address, bob.com, do you think bob.com is taken? I bet you it is. And I say I want to have bob.com. The people in charge of the directory, and there are people in charge of the web directory of all URLs, say, sorry, that one's taken. You can be bob9672.com if you want, but you can't be bob.com because it's already taken. There's somebody there with a list, and every time a new person wants an ID, they check that list and they decide whether or not it's okay, whether or not you're allowed to have that new ID. And that's what happens with web addresses. That's what happens with email addresses. When you go to Gmail and you choose a username, or go to anywhere pretty much and choose a username, first thing they do is they look it up against all the usernames that are there. If it's not taken, fine. If it is taken, no way. And then if you add that uniqueness onto the uniqueness of having this hierarchical set of qualifiers like gmail.com, then you see how you can make a complete unique address. Within Gmail, the directory guarantees the uniqueness within Gmail, right? That it's Bob 697 and nobody has that one. Now, between Gmail and all the other email addresses, all the other email servers, the directory of all of the .coms, it's gmail.com, right? So so the directory, the internet directory, guarantees the uniqueness there. We have uniqueness across the web, and then we have uniqueness within the server, and so we can have uniqueness of that address.